Hey guys, Mr. Betts here. I want to take a look at a type of problem that's kind of typical on the AP test, and that is here's a situation, which of the options fit that situation? So, in this particular example, we have a differential equation, and we want to know which of three functions are solutions to that differential equation. So, it could be none of them, it could be all of them, it could be some combination of those. So what we're going to do is just take these one at a time and plug in what we can, take derivatives to plug in what we need to, and figure out if each is a solution. So starting with the first equation here, notice that this goes up to the fourth derivative. So we have a second derivative here, we have a fourth derivative, and we have the original function. So to start with, I'm going to take the fourth derivative. So we'll start with the first derivative because you can't jump straight to the fourth derivative. And the derivative of sine is cosine. We're going to be multiplying by 2 with the chain rule. So we're going to have negative 3 halves cosine of 2x. Derivative of cosine is the opposite of sine, so that negative's getting canceled out. So we're going to have 3 sine of 2x multiplied by 2 because of the chain rule there. Third derivative, we're going to have 6 cosine of 2x. And then the fourth derivative, we're going to have negative 12 sine of 2x. So now we're going to take what we have here and plug it into the differential equation. So the fourth derivative is the negative 12 sine of 2x. And we have plus 4 times the second derivative, which is 3 sine of 2x. And then minus 32y, and y is the negative 3/4 sine of 2x. And if this is a solution, this should all equal 0. I'm putting a question mark there right now because we don't know if it's actually equal to 0. You may have noticed after these two terms, we have a negative 12 times the sine of 2x plus a 12 times the sine of 2x. And then we're going to have a plus 24 sine of 2x. So all of this, we can factor out a sine of 2x from. And negative 12 plus 12 is 0. So if we add 24, it's obviously not going to be 0. So this one is not a solution to this differential equation. If we look at the second example, we're going to go through the exact same process. So first derivative, using the chain rule, we're going to get 10 e to the 2x. Second derivative, 20 e to the 2x. Third derivative, 40 e to the 2x. And the fourth derivative, 80 e to the 2x. So plugging into our differential equation, we have the fourth derivative, 80 e to the 2x, plus 4 times the second derivative, which is 20 e to the 2x, minus 32 times the function, so 32 times 5 e to the 2x. And if this is a solution, then that is going to equal 0. So we have 80 e to the 2x plus 80 e to the 2x minus 32 times 5 is 160 e to the 2x. So I'm factoring out an e to the 2x here. And 80 plus 80 minus 160 is indeed 0. So we get 0 equals 0. Let me put the question mark there. So this is a solution to the differential equation. So we would include option number 2 in our answer. Number 3, this one looks pretty similar, except we have a different coefficient. So we still have the e to the 2x. So it's going to look a lot like the last one. So we'll have negative 6 e to the 2x for the first derivative, negative 12 e to the 2x for the second derivative, negative 24 e to the 2x for the third derivative, and negative 48 e to the 2x for the fourth derivative. So plugging into the differential equation, we're going to have negative 48 e to the 2x plus 4 times negative 12 e to the 2x minus 32 times negative 3 e to the 2x is equal to 0. Again, we don't know that it's equal, so I'm going to put a question mark there. So we have I'm going to put the e to the 2x out front. So negative 48 in the first term, negative 48 in the second term, negative 32 times negative 3 is positive 96 in the third term. So we want to know if that's equal to 0. And indeed, negative 48 minus 48 plus 96 is 0. So we get 0 equals 0. And we have confirmed that the third option is also a solution to this differential equation. It actually turns out that no matter what the coefficient is here, y equals k times e to the 2x for any k value will be a solution to this particular differential equation. So we just had two instances here. So if this were a multiple choice question, we would be looking for the option then that has 2 and 3 as our choices.